Hello students, so this is Dr. Dharan, your chemistry faculty at APJ Academy. Welcome you all to the fourth live stream of chemical kinetics chapter. सबसे पहले मैं आप सबको वेलकम कर दूं इस सेशन में एंड एज वी डिस्कस्ड जो पुराने लाइव्स में हमने डिस्कस किए थे चैप्टर्स को राइट वी डिस्कस्ड मल्टीपल factors about the chemical kinetics, about order, about rate of chemical equation. We discussed all those facts, correct? Discussed all those interesting facts on the chapter. So today what we'll do, we'll just continue our discussion with that, with a quick recap of what we discussed till now and about order and all those parts. So सबसे पहले guys मैं एक important point बता दूं आपको. We all know, right? What are we discussing today? We are discussing chemical kinetics chapter part 4 on the date of 5th May, that is 23. Clear? So now let us go with it. Okay, so सबसे पहले हमें पता है there is a reactant giving us a product. Just consider this example. Let us consider this. I am having a reactant giving me some products. Okay, this is a simple reaction. So इस reaction का it has some rate, correct? It has rate. So this rate of reaction, and there is a connection between the concentration of the reactants. Okay, that is nothing but R and A. इन दोनों का dependence, this dependence, the dependence of these two entities is given by rate law and order जो हम लोग डिस्कस कर रहे थे. ऑर्डर हेल्प्स टू एक्नॉलेज दिस. ऑर्डर हेल्प्स टू एक्नॉलेज दिस मतलब ऑर्डर से हम बता सकते हैं रेट एंड इसका रिलेशन. सी फॉर एग्जाम्पल एज वी नो व्हाट इज ऑर्डर. जैसे फॉर एग्जाम्पल हमने बताया a प्लस बी गिविंग मी सम प्रोडक्ट्स. तो अगर मैं इसके लिए रेट लॉ लिखूं तो r इज इक्वल टू k इंटू a पावर x b पावर y. करेक्ट. सिंपल अगर मैं सिंपल एक रिएक्शन एक और भी लिख लेता हूं तो उसके लिए भी आर क्या लिखा जाएगा रेट लॉ के अकॉर्डिंग ए पावर एन. सो अकॉर्डिंग टू दिस एन इज व्हाट? एन रिप्रेजेंट्स योर ऑर्डर. करेक्ट. हमने ये अभी तक डिस्कस किया. वी डिस्कस्ड ऑल दीज फैक्टर्स टिल नाउ. करेक्ट. सो व्हाट इज इट? एन इज योर ऑर्डर. दैट मीन्स and we also know that order values can be 0, 1, 2, 3, integer, fraction, whatever it is. Correct. We discussed that part. So now just what if I can substitute now अगर मैं 0 को यहाँ पे रिप्लेस करता हूँ, n की वैल्यू 0 रखता हूँ तो वो 0 ऑर्डर रहेगा. ये सब हमने डिस्कस कर दिया. तो what do you mean? अगर मतलब अगर ऑर्डर देखो, let us try to put these values. Okay, so let us consider first case. r is equals to k into a power 0 for 0 order. r is equals to k into a to the power 1. That is first order. r is equals to k into a to the power 2. This is second order. Okay, now let us totally focus on first order and 0 order first. Okay, let us focus on this first. See, we know that anything power to 0 is 1. Anything power to 1 is the same number. Correct. And anything power to 2 is square, cube, triple वगैरह सब पता है अपने को. Basics तो ये हमें पता है. These are your basics. Simply a power 0 is nothing but 1. So k r. So guys 0 order हो गया. Right. In 0 order we got r is equals to k. And what is k? हम सभी को पता है. K is what? K it is your rate constant. Clear? This is what? A reactant की concentration. Correct. These are the two things we got: reactant concentration and rate constant. So for 0 order n value is becoming 0. So that means in 0 order rate of the reaction is equals to what? Rate constant. And rate of this reaction is independent. Here comes the most important point here guys. Rate of the reaction R is independent on concentration of reactants. For which case? For 0 order reactions. दूसरी बात, अब आप थोड़ा लॉजिक लगाओ. ठीक है. Just apply some simple logic. Just think from a simple logic guys. See, what if is any chemical reaction possible when the concentration of the reactants is 0. Okay, that is not at all possible. Again, there are very few cases. Okay, there are very few cases of zero order kinetics, zero order chemical reactions. The chemical reactions which follow zero order kinetics are very few in number, but we'll discuss the further thing. Now, this was like the main purpose of order. Why this order came? Clear? We discussed multiple points about order. I want you to add these points as well there. Okay? Order explains dependency of rate of reaction on concentration of reactants. Correct? Order explains what? Explains dependency of rate of reaction for concentration of reactants. For example, as in case of zero order kinetics, we saw R is equals to K to the power into A power 0, that where our rate of the reaction is equals to rate constant and independent of concentration of reactant. This is the first part. Now second part, R is equals to K to the power A into A to the power 1. Now what is K actually? We know that it is rate constant. That means K is a fixed value, it is a constant value. So if I see the proportionality, rate of the reaction is directly proportional to concentration of reactants. That means here rate of reaction in first order part, in first order अगर जब order 1 होती है तो rate of the reaction जो होती है, rate of reaction is directly proportional to concentration of reactants. That is, if reactant की concentration increases, the rate increases. If concentration decreases, rate also decreases. But in first case, in zero order kinetics, it was not like this. So ये एक major difference बन जाता है zero order and first order में कि rate of the reaction is depending or not. And this totally, the entire concept is explained by the only single concept, that is nothing but your order. And we also know, just we should not forget, order it is an experimental. Order is what? It is an experimental value, guys. Order क्या होती है? Order एक experimental value है. It is an experimental value. That is simple as that. Correct? Now let us go to the different concepts now. Let us go with the like new concepts of today. We'll learn some new things today. Clear? So what is that? We have two different equations. Correct? So सबसे पहले जब हम लोग chapter start कर रहे थे, when we are starting the chapter, we had some reactions. We learned some new concepts like rate. Correct? We learned what is rate. We learned what is rate equation. We learned what is rate equation. So this rate equation, basically what we learned is there are two types of rate equation, guys. Okay, there are actually two types of rate equations. First, differential rate equation, the integrated rate equation. Integrated rate equation we'll study for zero order, first order, basically according to your NCERT. There is also for nth order and second order, pseudo order. There are multiple, but we'll mainly focus on zero and first order. Differential rate equation you know, okay, minus dc upon dt plus minus. So where is this? Plus is used for products, minus is used for reactants. Differentiation and integration. We'll use differentiation and integration in the derivation of formulas. That's it, nothing very much complicated. And we also know there are two types of rate. Clear? We also know, again, one more important thing here to notice, we are having two types of rate. One is the average rate, the second is the instantaneous rate. We discussed this. What is average rate? Final minus initial upon time. But instantaneous rate at a particular instant, at t is equals to 10th second, at t is equals to first second, like this, at particular instant. So now we'll talk about different radiation equations, and before going further, we'll add another point also here, guys. So we know what is K, right? Rate constant. So for example, let us consider A is giving me some products. Okay, now rate is equals to minus dA by dt is equals to k into a to the power n. Am I right? Very simple, correct? So this is k. So simply this is r, I'll write this as r. This entire term I'll write, keep it same. I'll keep this k as k and this as order. Let us consider for first order equation. Okay, just let us consider for first order equation. Let this n be 1. Okay. So now what is rate? It is dc. Now as we described the units, right? We have this unit as dc upon dt into 1 upon a is equals to k. So सबसे पहले r का dc upon dt we know. What is the unit of rate equation? That is concentration मतलब moles, time. So moles per liter upon time into moles per liter is equals to k. So this is the way you actually derive the units. You actually derive the units for the following integrated equations, and any किसी का भी equation अगर आपको derive करनी है तो आप ऐसे कर सकते हो. Clear? This is how you do the things. Now we'll go with the first order and zero order equations. Actually, what do you understand by zero order? What do you understand by first order? We'll go defining each of them and we'll go further. Clear, guys? So सबसे पहले we'll start with the topic of zero order reactions. Zero order. Clear? We'll start with zero order. So first of all, आपके दिमाग में सबसे whenever you hear this term, the one thing should come, n की value 0 है. Okay, that means r is equals to k into a power 0. This is what it should come to your mind. Okay. Second, zero order kinetics में just now we discussed. See, so that means r is equals to k. The second point, whenever someone says to you that it is having zero order kinetics, अगर कोई आपसे आके बोलता है कि कोई इक्वेशन कोई रिएक्शन जीरो ऑर्डर काइनेटिक्स फॉलो करती है, if someone asks you and says to you that a reaction is going zero order kinetics, the first point that should come to your mind, the first point that should strike your brain, it is that in zero order kinetics, rate of reaction is independent on concentration of reactants. Let us note this down, which is the most important statement. Rate of reaction is independent on concentration of reactants. Correct? So generally, like if we start about the equations, so now let us try to derive the integrated equations for zero order kinetics. Okay, so now simple, let us take a simple equation. Chemical reaction R, some products P. R is giving me products P. Correct? So now I'll write according to rate law. Let us go according to rate law. R yani rate is equals to minus dr upon dt is equals to k into r power 0. Am I right? Why 0? Because n की वैल्यू यहाँ पे 0 है, हम जीरो ऑर्डर काइनेटिक्स फॉलो कर रहे हैं. Correct? Very simple, as clear as mirror. Correct. Now, so just now let's solve the further equations. So minus dr is equals to k dt. Now what I'll do, I'll just integrate the equation. So now basically we're getting the final equations, integrated simple equation formulas, simple formulas for zero order and first order kinetics. We'll be doing that today. Okay. So now I'll integrate on both sides. Integration. Clear? I'll just keep this minus sign out of integration. Correct. And kdt, I have got this. Now very simple. After integrating, I have got as r. Correct. I have got this as r. Now this is r and I'll get minus kt plus I. I get this after integration. And what is this new term called I? Many might be having, those who are familiar with the integration, they'll know this I, it is basically an integration constant. What it is? It is an integration constant. Now let us understand this as equation 1. Consider that as equation 1. Clear? So now what is your equation 1? R is equals to minus kt plus I. This is your first equation. Clear? Now since we are considering what? Zero order kinetics. Correct? अभी हम लोग zero order देख रहे हैं. So let us consider at t is equals to 0, यानी initial time, like first initial जब reaction start हो रही होती है, like okay. So t is equals to 0. We all know we are talking what is r? It is the rate. Okay, this r is rate guys. ये जो r है ये आपका rate है. Okay, and this t is time. Let us please note down this, very important. Don't confuse it with reactant. This is your rate. This is your time. This is your rate constant. You know that. And this is your integration constant. Please make sure of it. Okay. Now, simple. T is equals to 0. R, a reactant concentration. Okay, we'll put reactant concentration at R, reactant concentration RT is 0, R naught. Okay, this is the initial reactant concentration. Let us consider at R naught. Okay, मतलब 0 times पे rate. Let us consider RT. Now what is RT here? यहाँ पे this is rate at t seconds. Rate at t time. Rate at 0 seconds. We'll just put the values. Now see, time is 0. Okay, just put there. So R naught, we'll get R naught. Okay, because time is 0 and at time 0 rate is R naught, that is equals to minus k, and time is 0, we'll put it and we'll get I. So from this R naught is equals to I. Okay, now let us be the second. Now I got the value of I, correct? Now I received the value of I. I'll just substitute this. I'll take this and put in first equation. So what do I get? I get R is equals to minus kt plus R naught. I'll just take kt here. Before going, minus kt plus R naught. So now this is one of the equation I got, right? अब please इसको ध्यान से देखो. What is it? How can you understand? Okay, this is one of the thing. Now I'll just take this R naught to other side and kt keeping the same side. I'll just rearrange it. I'll kt take at this side and I'll get R naught minus R. Correct? Now I got this equation. Very cool. अभी तक हम लोग अच्छा चल रहा है. kt is equals to R naught minus R. Now what is k? R naught minus R upon t. So this is what your integrated rate equation for the zero order kinetics. Clear? Clear, students? Any of you have any questions, any doubts? Please, you can, your live stream chat is always open. Please make sure you can write it there. All your points. Clear? All your points you can write it there. Simple. Correct? Now, before going further, now after the integration, I got this one beautiful expression here. R is equals to minus kt plus I. Let's work on that as well. Okay. So this is the integrated, what it is? It is the integrated zero order rate equation. Integrated rate constant equation for zero order. Okay. Now I got one there, 1 point. Y is R is equals to minus kt plus I. Compare it with y is equals to mx plus c. Okay. Now if I plot a graph, this is your y-axis, this is your x-axis. Y-axis, x-axis. Y-axis पे क्या है? I am having this rate R. Okay, this is the rate. And what do I have in x-axis? I am having time here. What is the slope, guys? Negative slope. So what is the graph comes here? This is, and this is your slope. This particular point is R naught. Okay, this particular point is R naught. That's the slope for zero order kinetics. Very simple, easy. Okay, this is your zero order. We done this zero order now. Clear? Now, very simple. Now what you have to do, we'll just take half-life. Okay, we discussed a concept called T half. What is T half? It is nothing but half-life. For example, I'm having reactant is converted to product. T is equals to 0. This is having A and this is 0. At T is equals to 10, A becomes A by 2. This becomes P by 2 something. At T is equals to 20, this becomes 0 and this becomes P. That means it is growing, correct? This is have been decreased by half. Here 50% is decreased. That is their half-life. Now simply we'll just go back to the equations again. Okay, this is for the first equation we got for zero order kinetics, correct? Now this is the final equation we got, correct? Simple. तो R naught पे लिया, ठीक है? So now at T is equals to 0, R becomes T. See now what happens? Your equation is R is equals to minus KT plus R naught. R is equals to minus KT plus I. That's absolutely correct. Now what happens at T half? At T half, RT becomes RT1 by 2, AT becomes A naught by 2, correct? A naught by 2. So this is what your equation, you can just develop the equations. That is very simple. Okay, and first of all, coming to the main point of zero order kinetics, one of the most important, what reactions come under zero order kinetics? कौन से ऐसे reactions हैं जो zero order kinetics follow करते हैं? कौन से ऐसे reactions हैं जो zero order kinetics follow करते हैं? Please make sure what is that. ये थोड़े important examples हैं, आप लोग लिख लें इन्हें. Okay, the important zero order reactions. Important zero order reactions are, first, usually these reactions, the most important point is usually these reactions are very rare, मतलब बहुत rare होते हैं, ठीक है, and occur under special circumstances. So ऐसे ही एक एग्जाम्पल है, ठीक है, all enzyme catalyzed. Okay, this is one of the reaction we got. Next, एक रिएक्शन है, ठीक है, ऐसे रिएक्शंस जहां पे मेटल सरफेस होती है, ठीक है. सो जैसे रिएक्शंस बताऊं मैं, एंजाइम कैटलाइज्ड रिएक्शन with metal surface. जैसे एग्जांपल की देखो, 2 moles of NH3 I'm having. Okay, I'm having 2 moles of NH3 at platinum surface of 130 Kelvin at this temperature. Platinum surface पे it gives me N2 plus 3H2. So इसका रेट ड्रॉ क्या होगा? R is equals to K into NH3 power 0. Why 0 not 2? It is 0 because it is zero order kinetics. This is one example. Second example, H2 plus Cl2 in presence of sunlight. All the photochemical reactions come under zero order kinetics, guys. HCl. Clear? So that means from this equation you can say all photochemical reactions follow zero order kinetics. Follow what? Zero order kinetics. Very simple. You have done this. You have done the zero order thing. So just I'm giving 2 minutes time, guys. Just please go through the entire derivation of zero order kinetics, what you have understood. Till that, next we'll start with the first order kinetics. So I hope everyone is done with the recap of this derivation, correct? So simply यहाँ पे क्या होता है, हमने क्या किया, सिंपल रेट इंटीग्रेशन यूज किया टाइम्स के थ्रू. वी जस्ट डिराइव्ड द इक्वेशन. टाइम t पे क्या होता है, टाइम 0 पे क्या होता है, वी डिड दिस थिंग एंड नाउ वी गॉट दिस. क्लियर? वेरी गुड. नाउ देयर इज अ सिंपल थिंग आई वांट टू टेल यू गाइस. ठीक है, एक स्टार मार्क की तरह अपने नोटबुक में लिख लो. यूनिट्स ऑफ k. This we skipped out. Actually, this went missed on. So there is a concept called units of k. Okay, so for zero order, for first order, for second order. So what is the unit? For zero order, it is mole, liter inverse, second inverse. For first order, it is just second inverse. For final, it is second order, it is mole inverse, liter in and second inverse. Okay, so there is a quick trick, like a trick जैसे हम लोग एक try करेंगे. Okay, I'll just show you. It is actually liter and second inverse. So why this is important? Because there are questions asked in the examinations कि why the hell, मतलब why द हेल लाइक कुछ रिएक्शंस दे देंगे, लेकिन वो लोग पूछते हैं पता नहीं क्यों ऐसे क्वेश्चन, सिंपल क्वेश्चंस होते हैं, काफी स्टूडेंट्स गलत भी करते हैं. दे विल जस्ट गिव यू द रेट वैल्यूज फॉर सम पर्टिकुलर इक्वेशंस. 4-5 रेट दे देंगे और आइडेंटिफाई ऑर्डर करने बोल देंगे. जैसे मैं खुद बताऊं, अभी मेरे पास 2 रिएक्शन है. पहला एक रेट की वैल्यू है मेरे पास 2.3 इंटू 10 पावर माइनस 5, 2.3 10 पावर माइनस 5. ओके, आई गॉट लीटर, मोल इनवर्स, सेकेंड इनवर्स. दूसरा रेट है मेरे पास 2.8 इंटू 10 पावर माइनस 4, सेकेंड इनवर्स. दिस आर द 2 रेट्स. दिस इज R1, दिस इज R2. अब इनका ऑर्डर बताओ. तो क्वेश्चन बी लाइक दिस आर द रेट्स, आइडेंटिफाई द ऑर्डर. जस्ट लुक एट द यूनिट्स. आप लोग यूनिट्स देख के बता सकते हो. सिर्फ सेकेंड इनवर्स है तो व्हाट इट इज द फर्स्ट ऑर्डर. नाउ मोल इनवर्स, सेकेंड इनवर्स एंड सिर्फ लीटर है तो व्हाट इट इज सेकेंड ऑर्डर. If I'm having, I'll say R3 is I'm having 10 into 10 power 12 mole liter inverse, second inverse. So what it is the first order. So these are the 3 important. So second inverse, second inverse, second inverse, सब चीज में common. moles per liter. liter inverse है तो 0, moles inverse है तो 2. moles liter inverse है तो 0, moles inverse liter है तो 2. Identify this, very simple. बाकी सब में सेकंड इनवर्स कॉमन है. तो फर्स्ट, अब यहाँ पे एक और इंपॉर्टेंट पॉइंट देखो तुम. ठीक है, फर्स्ट ऑर्डर में यूनिट्स पे ध्यान दो. फर्स्ट ऑर्डर की यूनिट सेकंड इनवर्स है और यूनिट्स में मोल्स लीटर नहीं है. एंड मोल्स लीटर किसके यूनिट्स है? कॉन्सेंट्रेशन के यूनिट्स है. करेक्ट. सो रेट ऑफ द रिएक्शन इज डायरेक्टली डिपेंडिंग ऑन ओनली टाइम. टाइम पे ही डिपेंड करती है, कॉन्सेंट्रेशन पे इंडिपेंडेंट है फर्स्ट ऑर्डर काइनेटिक्स. ओके, सो व्हाई इट इज सो? Okay, why it is so, that we'll study now in the first order equations. Clear? So now again we'll derive the same integrated equations as we did for zero order as in the first order case. Clear? First order by we'll describe this. So first order, now we'll start first order. That means n की value 1 होनी चाहिए. So what is it? How do you define first order equations? So for zero order equations, for zero order we define them as the reactions where the rate of reaction is independent on concentration of reactants. So this is the definition for zero order, guys. Let us define it here. We'll write the definition here somewhere so that you can understand it. Okay, if someone asks you define zero order, what you will say? You will say reactions in which rate of reaction is independent. What it is? It is independent on concentration of reactants. All such reactions are called zero order reactions. Now similarly, अगर first order reactions को मैं अगर define करूं, so if I try to define this, it will be the reactions in which reactions in which rate of reaction is directly proportional to concentrations of reactants. You know why? What does this mean, right? हमने अभी डिफाइन भी किया था, ठीक है. R is equal to k to the power a power 0, where k is nothing but your constant and R is directly proportional to A. What is this A? Concentration of reactants. For the reaction A is giving me product. इस equation के लिए. For this equation, this is what the rate of first order. So there are pretty much examples, guys. ठीक है, first order के काफी सारे examples हैं. I'll tell you all the examples of it. A list of examples I'll give you at the end. But for now, what I am trying to tell you is, let's define the equations. Okay, हम लोग integrated equations को derive कर देते हैं पहले. Okay, ठीक है, simple है. मेरे पास reactions ले लेते हैं. Let us take some reactions. A is giving me, सबका favorite, A is giving me some products. This is the reaction. So now 0 time पे what is the concentration I am having? A. At after time t seconds के बाद I am having A minus x. This is 0 and some x is formed. Clear? Some extra amount of product is formed that is being reduced from the reactant, A minus x. This is simple. Clear? So minus d A by dt is equals to k into A to the power 1. Y power यहाँ पे n की value 1 है, this is because it is the first order. We are talking about what? We are talking about first order, guys. Clear? We are talking about first order. Now this is done. So now just try to rearrange the entire equation. Okay, just try to rearrange the entire equation you have got. So this is for respect with reactant. So what about with the products? Products कैसे लिखूं? अगर ये ऐसा लिख सकता हूं मैं, तो I can also write dx by dt. Correct? I can write dx by dt. Okay, if I can write in the terms of reactants, मैंने इस पूरा reactant के terms पे लिखा, तो मैं products P यानी product की concentration के terms पे भी लिख सकता हूँ, right? तो वो कैसे लिखूंगा मैं? dx by dt is equals to, okay, dx by dt, basically dx by dt, that is equals to at t seconds के बाद I'll get k into a minus x. Correct? I'll get k into a minus x. So what is actually dx by dt? So dx by dt is basically the rate with respect to products. मतलब x amount तो फॉर्म हुआ t seconds के बाद, ठीक है. This is at t is equals to 0 seconds. Now if I'll just go on with the derivation, guys. Okay, so what do you have got now? Simple. dA by dt is equals to ka. We'll just integrate this equation first. ठीक है, I have got dA by dt is equals to k power into a. I'll just integrate minus dA. This is the integration we are doing now, and after doing that I'll get minus logarithm a. See, since it's fractional and you're now what is ln here? Ln is natural logarithm. ठीक है, ln क्या है? ln एक natural logarithm है at t seconds. Okay, ln at with kt plus I. And what is this I? Everyone knows it is the integration constant. Integration constant. Okay, now similarly at t is equals to 0, this is the equation, general equation we have got. अब t equals to 0 पे लगाते हैं, ठीक है. t is equals to 0 में लगाया, t की वैल्यू 0 किया तो minus l naught at will become what? a naught. Okay, at becomes a naught. So simply what do you get? Just keep that as a, k into 0 plus I. This becomes a naught. So this is this is as considered as 1. and this as 2. Now we'll just put 2 in 1. Okay, minus ln at is equals to k into t plus minus ln a naught. So we are just talking everything in the terms of natural logarithm. यहाँ पे हम हर चीज natural logarithm के थ्रू बात कर रहे हैं. कुछ भी यहाँ पे हम लोग what do you say, we are not considering in the log. ठीक है, 2.303 जो log होती है तो वो नहीं करते, तो वो अभी हम लोग नहीं करेंगे. we'll just do that in the end. Okay, so natural logarithm ln and log. तो अगर इसको ऐसे कन्वर्ट करना है तो you'll just multiply we'll just multiply the natural logarithm value into 2.303. 2.303 से मल्टीप्लाई कर देते हैं उसको. So that is how you convert natural logarithm into the logarithm to the base 10. Natural logarithm मतलब क्या होता है, log की बेस में ही होती है, और normal log 10, यहाँ पे log 2 वैल्यू हो गया, जैसे log 3 वैल्यूज होते हैं, इन सारे के बेसिस 10s होते हैं. So you'll just will conduct an important session on logs and how to do that in the coming future. For now, just keep in mind. Okay, this is what we have got till now. Okay, we'll just open the bracket there. Minus ln at is equals to kt minus ln a naught. Now, very important. Now I'll just make some rearrangement in this. ठीक है, अब rearrangement कर देते हैं. ये minus minus signs को हटा देते हैं. And after taking the minus signs and rearranging the equation, I'll get ln at is equals to ln a naught minus kt. Now बहुत ही important सी चीज यहाँ पे ध्यान देखो. ठीक है, बहुत important है. This is your y, this is your mx, c. This is the equation. Okay, so अगर ये एक बहुत ही important equation बन गया आपका पहला integrated equation for first order equation, you have got this. You got beautifully derived. You got negative slope, you got y-axis, you got x-axis, and everything is there. Simple, correct? This is got your first thing. Now I'll just again do some rearranging in this. So what I got till now, अभी हमारे पास है ln at is equals to ln a naught minus kt. This is what you have got, correct? Now what I'll do, I'll just keep the kt over there. Okay, मैं kt को इस तरफ लाता हूँ. I'll just bring the kt this side, and I'll take ln a naught becomes by ln at. Okay, मैंने क्या किया, kt को उस तरफ ले गया to just make it positive sign. I got kt that side, I took the ln at this side. So this is kt, this is ln at. Okay, so basically a naught. What is your a naught as मतलब at and a naught? This is your basically a naught and this is your basically at. मतलब concentration at t seconds, concentration at 0 second. Just substitute the values there. A upon a minus x. I got the main equation. kt is equals to ln upon. ये एक important simple equation बन गया, आपको याद करने लायक हो गया. Good, everything is good, perfect. अब now what I'll just do, I want k value. I want just k equation. K ln a minus x into 1 upon t आ गया. अब मैं क्या कर रहा हूँ, नेचुरल लॉगरिथम को I'll just convert into to the base 10. तो सिंपली क्या करने बोला था मैंने, उसको 2.303 से मल्टीप्लाई करनी है. तो व्हाट यू विल गेट, 2.303 अपॉन t log a naught minus 80. It is 2.303 upon t log a minus x. Simple. Clear? This is the integrated rate constant equation for first order. So let us conclude. For first order, what you have got, the main equation ln at ln a naught minus kt. So ln at ln a naught minus kt. Okay, simply this is the general equation we have got. हो गया, ये सिंपल खत्म हो गया. ये कर लिया अपन. y is equals to mx plus c. मतलब ग्राफ कर लेते हैं. अगेन सिंपल, इसका भी ग्राफ वेरी सिमिलर जैसे पिछले जैसा. नेगेटिव स्लोप होगा, x एक्सिस यहाँ पे log a, यहाँ पे टाइम, और ये आपका स्लोप minus 1 because it is a negative slope. Clear? We got this at negative slow. That we did. But now, and what is it? It is actually 80, guys. Okay, that is an 80. Okay. Now there are actually some pretty much applications for this. ठीक है, फर्स्ट ऑर्डर के कुछ एप्लीकेशंस हैं, बहुत ही इंपॉर्टेंट एप्लीकेशंस हैं फर्स्ट ऑर्डर के. सो व्हाट आर दोज एप्लीकेशंस, आई विल टेल यू. And before going to the applications, let us try to understand some examples of first order kinetics. Let us try to understand what? Some examples of kinetics. So these are the list of examples that follow first order. सबसे पहला रिएक्शन है आपका NH4NO2. NH4NO2 giving me N2 plus what? And water molecule. Clear? Now CH3COOC2H5, all your esters, esterification reactions with water molecule, जब वो react करते हैं, what do you get? You get an alcohol and a carboxylic acid. CH3COOH, carboxylic acid plus an alcohol, C2H5OH. Now you also have hydrogen peroxide dissociation, H2O2 guys. H2O2 क्या होता है? H2O प्लस O2 में स्प्लिट होती है, तो जस्ट बैलेंस टू H2O, ये 2H2O. सो दिस इज ऑल्सो फॉलोइंग योर फर्स्ट ऑर्डर काइनेटिक्स. ठीक है, एंड ऑल radioactive decays follow first order kinetics. Follow what? First order kinetics, guys. So, and we also know what is the units of K here. It is nothing but second inverse. Second inverse is the first order kinetic equation for this. Clear? Second is the first order kinetic equation for this. This is what we know till now. Correct? Now, there are actually pretty much some examples of it. ठीक है, थोड़े applications, not examples, we can say it is like an application. ठीक है, half life define कर दें इनका, because T is equals to जब T half, so we are having T is equals to 0, T is equals to T seconds. These are the three cases that usually we have. Okay, so this is what we have got, right? So we'll have, and we also have one more, T is equals to T 3/4. मतलब 3/4 of the reaction जब complete होती है, तब वहाँ पे equation what happens, that we have to understand. Okay, so simple सी बात है, T half consider करते हैं. So at T is equals to T 1/2 half में, what happens? Your x is a/2. X is a/2. X is equals to a/2. What is x? What do you mean by x is equals to a/2? मतलब ये जो x है ना, ये a/2 है, तो यानी this will become a/2 at T 1/2, T half में, मतलब हाफ में डिक्रीज हो जाएगा और कुछ नहीं है. ठीक है, यानी यहाँ पे a is equals to a रहेगा, a minus x will become a/2. तो a कैंसिल होकर 2 पर जाएगा. We'll just figure that out how it will work. Clear? So simple equation बना दिया हमने, just substitute कर देंगे यहाँ पे. I got already this kt is equals to ln a upon a minus x. I'll just substitute there. Now what is the equation I got? ln is equals to a upon a minus x. Correct? Kt is equals to ln into a upon a minus x. We'll just write that down here and we'll just substitute the values. So we'll get T half. So Kt is equals to ln a upon a minus x. You know this. Correct? Simple equation और भी पता है आपको, 2.303 upon T log a upon a minus x. ये भी पता है आपको. ठीक है, तो इसमें सब्स्टिट्यूट कर दो वैल्यू सारी आपकी. तो ln becomes a upon a minus x. What is x? a/2. So it is just becoming simple. You have just to substitute there, guys, और कुछ नहीं है. ठीक है, a becomes a minus x is a/2, so that is 2, natural logarithm 2. Correct? Natural logarithm 2. So I'll just, what do? I have to substitute these values here. ठीक है, 2.303 upon k. So I'll just get 1 upon, since you are calculating not k, we'll just do one early step here. एक पहला ही कर लेते हैं. T half कर रहे हैं ना हम लोग, तो t को उधर भेज के k इधर कर लेते हैं, ठीक है। सिंपली विल जस्ट शिफ्ट द वैल्यूज, दिस इज योर t1/2 एंड दिस इज योर k, करेक्ट। t हाफ कर रहे हो हम लोग एनी हाउ, सो 1/k ln 1/k, I got ln a/2, simple 1/k into ln2. Okay, simple equation. I'll just talk in natural logarithms for you not to confuse everything. Okay, ln a/2, so it is nothing but ln 2/k. ये आ गया हमारा। अब मैं इसको सिंपली अगर फिर से अगर मैं इक्वेशन में कंसिडर कर दूं, सो आई एम जस्ट कन्वर्टिंग इट टू अ नॉर्मल थिंग, 2.303/k log 2। log 2 की वैल्यू क्या है, 0.3010, 0.3010, you just substitute there and you'll get 0.693/k, that is your t half for first order. Similarly, so t half is nothing but 0.693/k. Okay, 0.693/k or 2.303/k log 2 or 1/k ln 2/k, natural logarithm 2/k, that is t half for first order. Now t half for 3/4, so t1/2 becomes now t3/4. Okay, so initially it was a, it become a/2, now it will become a/4. What will become a/4? That means, so आप खुद समझो, a is giving product, ये a था, फिर ये a/2 हुआ, फिर ये a/4 हुआ, तो that means a/2 यहाँ पे बना तो ये भी a/2 होगा। प्रोडक्ट क्या हो रहा है, प्रोडक्ट 3a/4 हो रही है, ठीक है, प्रोडक्ट 3a/4 हो रही है, प्रोडक्ट इज इंक्रीजिंग एंड दिस इज डिक्रीजिंग, दिस इज व्हाट द ट्रेंड एक्चुअली गोज ऑन, हाउ इट गोज। सो आप लोग को वो समझ में आ ही गया होगा, तो विल जस्ट सब्स्टिट्यूट द वैल्यूज नाउ, ठीक है। इंस्टेड ऑफ नाउ पहले x क्या था, वी टुक x as a/2, नाउ विल टेक x as 3a/4. okay, now what we'll do, so x is here now 3a/4, so what is a minus x, will get a minus x is nothing but a/4, correct। so जहां जहां पे हमने 2 सब्स्टिट्यूट किया था, a/2 सब्स्टिट्यूट किया था, right, what we did earlier, kt is equals to ln a/a minus x, correct, we did that। now we'll all you have to substitute is a minus x is a/4, so I'll just put ln a/4, that is 4 ln, so kt is equals to 4 ln, I got simple equation। now I'll just solve the further, kt is equals to 4 ln, so since it is 3/4, I'll just take 2.303/k into log 4, we can write that log 4, simple। now so agar abhi will not complicate it much, we'll just do one thing, okay, we'll just do, since it's log 4, we can know, right, you know that a log b, मतलब आप कैसे लिख सकते हो, see we know that 4 can be written as 2 into 4, 2 into 2, sorry, 2.303/k, ठीक है, तो log 2 into 2 लिख सकते हैं, तो what happens, this 2 comes in front, so 2.303/k into 2 log 2 into 2 log 2। now guys, अब ये तो वैल्यू आ गया आपका, ठीक है, दिस इज योर t3/4। now before going further, I want you guys to pay attention one beautiful thing, सिर्फ इस पार्ट को देखो, ये जो मैं हाईलाइट कर रहा हूँ, इस 2 को छोड़ दो और ये log 2 और ये पूरा देखो, 2.303/k और log 2, ये क्या था, what was your t half, t half is 2.303/k into log 2, ये पूरा t half है 0.693/k, पूरा t half है, तो can I write as 2 into t1/2, that is nothing but 2 into t half, that is log 2 0.693/k, I can write it, This is what here, this is 3 by 4. This is your 3 by 4. Clear? That is your 3 by 4. Very clear? So I got the equations now. First of all equations एक बार सारी summarize कर लेते हैं हम लोग first order के. So for first order I got first equation kt is equal to ln a by a minus x. So now अब ये एक equation आपको आ चुका है, right? This is the sole equation that everyone must remember. अब इससे तुम बाकी सारी फॉर्मूलाज तुम डिराइव खुद कर सकते हो. अगर एग्जाम में भी भूल जाते हो तो आप डेरिवेशन खुद कर लग सकते हो. तो व्हाट इज ए नॉट यानी इनिशियल कॉन्सेंट्रेशन. ठीक है, रिएक्टेंट की इनिशियल कॉन्सेंट्रेशन. ए माइनस एक्स क्या है? रिएक्टेंट कॉन्सेंट्रेशन एज आफ्टर टी सेकेंड्स. क्लियर? नाउ सो सिंपल. अब पूरी लॉजिक एक बार लगाते हैं हम लोग. आई एम हैविंग द रिएक्टेंट्स. This is my reactants. Okay, I just let us take it off. Reactant is giving me product. So now just take T is equal to 0, T is equal to T half, T is equal to T3 by 4, and after T is equal to T second. T seconds पे क्या होते हैं? तो इनिशियली ये था भाई और ये 0. T half में क्या हुआ? ये A by 2 हुआ. तो ये क्या बन गया? ये a by 2 बन गया. 3/4 मतलब 75% कम हो गया. तो ये a by 4, 3a by 4 और ये 0 और ये a. So this is the basic logic that everyone understands. If I'm talking about an hypothetical situation here, पूरा reaction ऐसे खत्म हो गया. Clear? Now simply, so what are this? ये सारी आपकी, this is your a naught. All these are your a minus x values and all these are your x values. Okay, all these are your a minus x. This is x. Substitute these values there, you'll get the formula. So for example for t half के लिए देखते हैं हम लोग. सबसे पहले I'll get kt into ln. a के जगह पे वैल्यू हमारे पास क्या है? a तो a ही रहेगा इनिशियल. करेक्ट? a minus x. What है t half मेरे a minus x क्या है? a by 2. तो what it is? ln 2. So kt half, correct? This is at kt half. So kt half is equal to ln 2 upon k. That is nothing but 0.693 upon k. If I consider as 2.303 k log 2. ठीक है, ये हो गया तुम्हारा t half के लिए. Similarly, very similarly, let's go for 3 by 4. k t 3 by 4 ln a by 4, because what is your a minus x? It is a by 4. That is nothing but 4. Okay, so t3 by 4 I can write it as ln 4 upon k. So that is nothing but 2 into t half. I got the formula 2t half. So this is the first order equation. And what is the unit of k? It is second inverse. Now basically if you talk about the examples as we discussed earlier, all radioactive reactions come under first order. All enzyme catalyzed with metal surface come under zero order. इसका एग्जाम्पल क्या है? NH3 at platinum 1130 केल्विन. ऑल रेडियो एक्टिव तो आपको पता ही है, यूरेनियम, न्यूक्लियर रिएक्शंस, ये सारी रिएक्शंस तो आती ही हैं फर्स्ट ऑर्डर का. और एक बेस्ट एग्जांपल, सबको याद रहने वाला एग्जांपल, H2O2 गिविंग मी H2O plus O2, हाइड्रोजन पेरोक्साइड का डिसोसिएशन है ना. एंड फॉर जीरो ऑर्डर में एक और, ऑल फोटोकेमिकल, जैसे H2 plus Cl2 in sunlight giving me HCl. Clear? In sunlight giving me HCl. These are the important guys. And for the again comparison में zero and first order, just quick comparison between zero and first order equations. ठीक है, zero order में और first order में. First order में rate of reaction is directly proportional to concentration. Here R is equal to K. This is the major difference between them. एंड फॉर जीरो ऑर्डर के की यूनिट्स क्या थे गाइस? मोल, लीटर इनवर्स, सेकंड इनवर्स, second inverse. So for first order you have only the unit as second inverse, for zero order you have only the unit as mole, liter inverse, second inverse. Correct? Mole, liter inverse, second inverse. So this is how you calculated all the things. Correct? Very simple. Now, so abhi what we did here, yahan pe the time is we have taken t half 3/4 t seconds. Very simple we have taken here. Now there are some pretty much questions. That is the last concept, like T1 and T2. What if there is a difference of time? Like T is equals to 0, T is equals to T1, T is equals to T2. So what at ऐसे equations पे how your equation becomes? So KT is equals to ln A by A minus X. This everyone should remember. ठीक है? To convert into natural log, the normal thing, you will just have to multiply by 2.303 A by A minus X. If you want K, you'll just put T here. If you want T, you'll just put K here. Simple 2.0 ऐसे करना, ठीक है? उससे log आ जाएगा आपका। और अरे हाँ, इधर आपको log भी दिखना है. That is important. Clear? So now for difference of for time intervals. So for interval formula, it is called as interval formula. What is interval formula? पहला तो t is equals to 0, फिर t is equals to t1, फिर t is equals to t2. ऐसे इसमें k की यूनिट क्या होंगी? तो फॉर दैट k is equals to 2.303 t2 minus t1, final minus initial, t2 minus t1 log a minus x1 a minus x2. तो what is a minus x1 and a minus x2? सिंपल, मान लो मेरे पास a है और मुझे प्रोडक्ट्स मिल रहा है, ठीक है? t इज इक्वल्स टू 0 पे ये a था और ये 0 था, ठीक है? t इज इक्वल्स टू t1 में मुझे प्रोडक्ट x1 मिला, तो ये मुझे x1 मिला। अब t2 सेकेंड्स, सो 0 से टाइम चालू है, आफ्टर t1 सेकेंड्स it become a minus x1, after t2 seconds the product is now x2, and after if this is x2 it will become a minus x2. Clear? A minus x2. So that sums up your integrated equations for the zero order and first order. So till now guys we have completed zero order के examples, first order के examples, zero order के chemical equation, the integrated rate equations, differential rate equations. We understood what are the examples of zero order and first order. We understood the graphs, very pretty much simple graphs. There are some particular half-life and other graphs that are actually important for IITs but not actually that much important for NEET. So ऐसे additional points हैं जो out of the syllabus and highly important points हैं जो IIT aspirants और उनके लिए हैं, वो points भी हम लोग cover करेंगे आने वाले sessions में. उनके लिए एक particular session होगा. I'll not combine मैं वो सारी high level points को इसमें complete live streams में नहीं करूँगा. We'll take that in the coming sessions. Okay, अभी के लिए इतना ही. I hope the session was informative and you guys could learn something. So if you just like this session, you just अगर आपको पसंद आता है, आपके thoughts, आपके comments, आप please हमारे comment section में live chat में आप लोग लिख सकते हैं. You can always, the comment section is free for you all. You can give your views, you can give your opinions, you can give what you expect, what is the topic that you want to learn in the further coming sessions. आपको कौन सी topic that you want to learn, what is the particular concept, is there any particular chapter you want to learn, you can mention in the comment box. Until that, if you like it, please give it a thumbs up, share it with your friends, ask your friends to learn the concepts, and all the very best. And all the NEET aspirants who are having the examination on May 7, 2023, a big and wish you a very all the best from APJ and from my side as well. That's it for today guys. This is Dr. Dharan signing off. We'll meet again in the coming week with another important and beautiful session of live stream of chapter chemical kinetics with it.